some of the past year question as well. So I copy past year questions, right? Can't remember last year, I think. And there was 2 questions. The other one is questions on fluorescence. This one in the presence of second molecule. So this is biomolecular reactions. Anyway, but I'm not going to go to the second part. The first part, this is basically straightforward from your lecture notes, right? You mentioned before as well, right? In the first tutorial, the question give the differences between photosystem 1 and photosystem 2. My part, normally, if you look at the mark there, right? My part, this first question is 10 mark. The second question is 15 mark. So 25 mark from me, from our part. So photochemistry contribute 25 marks. Everything is a quarter, right? Everything is quarter. Your tutorial is quarter as well. Of the exam and continuous assessment is a quarter. And then you have 1 unit for your laboratory, if I'm not mistaken. Right. So if you have this kind of question, it's bonus mark. You can write, this is just, I give you examples from the lecture note. Sometimes we mention it in our lectures. You can add them up, okay? You can add them. I just cut and paste. You see those text missing as well, okay? So the question is, give differences. You can, I just put a table here so that, it's easy. You can actually compare the two, all right, between photosystem 1 and photosystem 2. Even here, not even mention, for example, photosystem 1, and we call it why photosystem 1, photosystem 2, because even though one is dark, one is light, so it is actually the photosystem 1 is found first, then later on photosystem 2. This is the difference, in the name itself is different. So you can add them, what's the difference, right? So the differences, they are not actually the same, right? Okay, so before I came here this morning, right, I just Googled in the internet, right? This morning I just Googled internet, so there are some extra notes from internet that you can get, right? You can get straight away from internet. So this is the same as well, right? We can get that from internet. So we remember this is Stern-Bolmer equation, right? And it's the same as internet. It's just that the symbol may be different, right? The symbol may be different. Okay. What else? Yeah, I just have those two. Okay. All right. Later on, we go and for you to try out. Okay. All right. Now, if you go through your lecture notes, right? You go through your lecture notes. Basically, there are a lot of formulas. There are formulas in your lecture notes, right? Just this one, actually, I grabbed it from your lecture notes. Don't worry, you don't have to copy them, right? You can go back your note number 1. You can have the formula for fluorescent lifetimes, right? Basically, if you look at that equations, you can actually relate to the decay and rate constant when talk of lifetime, half-life. Okay, so they are the same. If you're asking you the half-life of the fluorescent, all right. So you're talking about half-life when the amount actually the total amount or total intensity become half from the T0, right? So you can we can find out quite easily for the half-life. So similar to your physical 2 sections last time when asking when you were taught about first order, zero order, first order, second order reaction. At the same time, there's half-life of the reaction as well. Basically, a repeat of your first year. So I don't talk about that, but you can use that as well when you're asking about half-life time. So this is with regard to the rate. And then when you look at the lifetime, okay, 1 over, so it is a sum of, right, when it coming down from intersection crossing, right, internal conversions, and this is bimolecular and fluorescence, right, and then the amount of the quencher that you have. So the KQ can actually determine, right, from this formula, right. So the bottom part, okay, the bottom part of the formula. So this one without the quencher and with the quencher, and the slope actually KQ over F, right? When you don't have the KF, for instance, you can determine the KQ, right? See the first equation over here, you have the KQ, right? So for the second one, right, in your notes, I'm not sure you have tried it out or not. I'm not sure you have tried it out or not. Okay. This one, as I mentioned, regard to rate order of reaction. So to determine the first order rate of reactions. Okay. So first order, you natural log, right? Whatever concentrations or intensity, which is physical changes, right? Physical changes, any physical changes, okay? Any physical changes in natural log, you plot it against the times of decay in this case, right? You should get a straight line. You get a straight line. Okay, we're going back to this one. So the straight line graph is, in this case, the answer, I just put the answer on 51,500 per second. We get to look at it because I have examples that I plotted as well. So remember, you are doing it in using a computer, using on full scope paper, not a computer. But now I think things have changed. But again, if you are using computer, you have to show the how you solve this problem. Jalan kena, all the steps must be there as well. Okay. Now, if you have biomolecular, this is in your lecture note. It's the same. I just repeat the what I mentioned just now. So the intercept is 1 because y equal to mx, okay, variable y versus variable x, okay. So y equal to mx plus c. So the constancy over here is 1. So you expect that the plot will intercept at y-axis, unit 1 of x-axis. Oh, sorry, y-axis. Okay, so you have the fluorescent intensity without the quencher and with the quencher. Okay, right. So the slope is KQ over KF. Remember, the slope is KQ over KF. So it's not actually finalized what the value of KQ and KF that you have. So as a symbol, I'm just telling you the slope actually referring to the value of the quenching rate and the rate constant quenching and the fluorescence. Okay, and this part. Okay, you got that? Anybody's coming? Hold on a sec. Okay, someone is coming. right? Para is coming. Don't forget. Okay. Don't forget. Key in. Log in your para. Sign in your attendant. Where is it? Okay. So this is another formula that you have, right? If you go down here, right? This is the one that you have in that question just now, and the question just now. So in this plot, right, you have the fluorescent lifetimes, right? Remember, you have the fluorescent lifetimes, right? So y equal to mx plus c. So the kf here actually the intercept. Okay, if you plot reciprocal of fluorescent lifetime versus intensity versus concentration, so q is the quencher concentration. Sometimes, it's not telling you the concentration, so don't find the concentration there. Any physical changes, I mentioned it, any physical changes, okay? So that reflect to concentration, intensity, for instance, right? Intensity, or if the question giving you the mass spec, right? The mass spec of HPLC and mass spec. So is how much actually left, for instance, right? So maybe involve some reaction, for instance. So it's almost impossible, but it can occur as well because reaction may lead to a product. So you lose the intensity or you lose the compound as it goes at the same times. But if you have the intensity, right, actually reflect to the concentrations. Right? Intensity reflect to the concentrations because this is biomolecular reactions. Okay, assuming there's no product is forming from the excitation energy, right, taken by the product, right? You're assuming that it won't happen. I won't put that difficult questions in here. So most of the time it's just intensity. Okay, most of the time it's just intensity or the concentration. I think intensity or the concentration, just to see whether you grasp the idea or not. Okay. So the reciprocal of fluorescence and then the slope, you see this is y equal to mx plus c. So this one is also the same, right? Okay, this is reciprocal. So if you have the y equal to c plus mx, so you have the variable here. Okay. Now this one actually the slope. Okay. So if you plot this, you should get a slope. So cross section, cross at this k value should be y-axis somewhere. All right. K value. Okay. And from the slope, right, you go back to the previous equations. All right. And how many of you have tried this this example? Quiet, how many of you? So an experimental fluorescent quenching of pyrene in solution gave the following information: determine Kf and Kq for pyrene in the presence of the quencher. In the presence of the quencher. So over here, right, you have the different concentrations, right? You have the fluorescent lifetimes, okay? Right? And yeah, sorry about this because the line actually when it plot and transfer, it's not. Forgive about who did this. So anyway, so you should expect, okay, that the intercept here, right? This is AF intercepts, and you should get the slope or gradients from here. So you get the difference, delta X, and you get the difference here, delta Y. Okay, so remember, right, gradients or slope, nanti ada tanya pula, saya ajar slope tapi soalan bagi gradient. So it's the same lah, right? Basically this is dy dx, dy over dx, right? Delta y delta x, you find that delta y over delta x. Okay, so you have data point here, and whatever data there. Okay, so the value here, right, about 2 times 10 of 6 unit is per second intercept, right? So the slope, you get 3 times 10 to the 9 unit is per second, AQ. Okay, so this is another from your lecture note, so I'm going to skip this, right? Okay, I'm going to skip this, right? I show you until we get the answer there, right? And this is another example. There are plenty of example in your lecture notes. You can try it out, right? So if you take this one, for instance, the quenching of tryptophan for fluorescent by dissolved O2, oxygen gas, right, was monitored by measuring the emission lifetimes at 348 nanometer, right, aqueous. So in here, I may ask you in energy, EV, for instance. So in one question, I can ask you, right? Actually, there's two parts here, right? You can ask you the EV over here, and I can ask you, which one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it belongs to this, right? Sorry about this, right? And belong to that. Okay, so now when you have 10 to the power 9, don't forget, in your calculator, sometimes you have, let's say, 2.6. Oops. Fluorescent lifetime equal to 2.6 seconds. It's not 2.6 seconds. Remember, you have this one. So 2.6 times 10 to the power minus 9. That. So unit is second. In your computer, in your calculator, right, you can write 2.6. I think computers are the same, E minus 9. Okay, isn't it? So don't make a mistake. Don't forget this. Don't forget this. You forget that, then your value way up. So a lot of students, many students actually, this is very common. Not just my student, other people's students also the same. Right? Could be the same person. I don't know, but very common. So this one I just cut and paste from your lecture note. I just put it here. Right? All of them. So we are talking about this just now, right? Okay, and this is another equations, Stern-Volmer equation. See, they are related to each other, right? KQ over here. Same. Okay. You can, if you have the frozen lifetime, you can get KQ over here. So for stern warmer, you can get KQ over here, for instance, for this equation, right? And sorry, this one can be lifetimes of tau not of fluorescent over, sorry, tau, right? With and without. Okay, with, without, quencher. This is bimolecular, and with quencher. Can you see that? Okay. So, but typically you are given with quencher only, right? So you can ignore the other part. So if you have this, right? So you have the slope, KQ, for instance. So in this case, you have KQ, KQ is the same question, right? You can put a KQ over here if it's the same questions, right? And then you can have KF. So just like in the other questions. Isn't it? Okay. Now, my questions, my part only 25 marks. Normally like one maximum is 25 marks. I just write here. My part is 25% of total, right? Of the 100%. Okay. Typically questions, right? I don't have one question most of the time, right? So we're talking about 2 to 4 lah, 2 to 4, 2 to 4. Sometimes just 2 questions, right? Or just 2 questions, right? Or 3 questions. Okay. So if it is like 3 questions, so more likely short question like 5 marks. So plot normally for this type of plot, it can go to 10 to, for plot, mark is 10 to 15 marks normally. Quite a lot, okay, quite a lot. So don't make a mistake, all right? Because once you make a mistake, you lost this 10 to 15 marks, all right? And subjective, other question is 10 marks. So 10 marks, right? This one could be sometimes divided into 5 marks and 5 marks. So that's why it becomes 3, all right? So if the plot actually 10 marks, so another 5 marks, right? So this one is another 5 marks lah. Or 5, 10, and so on. So maximum is 4, right? Minimum is 2 questions. Okay, on my part. So very short. So if you know how to do it, you can finish, right? Within half an hour. Okay, or less than half an hour. Right. We go back to these questions that we fleshed it out earlier. Right. Laser induced fluorescence of CH radical in the presence of excess O2. So the word is excess, so excess, which means the concentration of O2, right, final minus concentration of O2 initial equal to 0, right? This minus this equal to concentrations of, sorry, the other way around. T0, sorry, this one is final, right? So there's no change basically, right? Insignificance, no change in concentration. This one we are looking into the kinetic, there's no change because excess, that's what I mean in excess. Sometimes in a kinetic equation, in excess of acid, and there's no change in the acid. All right. So if we are looking at DO2, right? Change in DO2, rate of change DO2 over dt, basically zero. There's no change. Okay, that's what it means. Right? That's what it means. So no change. Right? So in this case, straightforward, very straightforward, because the question is asking you pseudo first order rate coefficient. Right? Pseudo order rate coefficient. Right? When first order, that's why you are plotting, right? You integrate the first order, right? Then you have the natural log lah, because you have 1 over concentration, isn't it? So you have 1 over concentration. Okay, then once you integrate 1 over concentration, it becomes the natural log lah, concentration. Okay, natural log concentration. So versus T. Okay. Now, the slope is your rate constant. In this case, rate constant of decay lah. Okay. So I just cut and paste. Right. I very quickly I did this part very quickly. So don't include this. Don't include this. So don't waste your time writing all those. So this can 5, right? So don't write all the numbers. Don't write all the numbers. Make it easy. 2 decimal place. 2 decimal place. Right? Or you can delete this. Right? You can turn it into 4. You can delete this. You can turn it into 3. You can delete this. Okay. So this one become 1, 0. Okay. Don't write all the numbers. Right? I'm not showing you to write the numbers in your answer script. Okay. Right. Something like that. Okay. So you are given this value. What I did was, okay, this one in the, remember, is microsecond. So 20 times 10 to the power minus 6 second. Okay. Do not copy if you, don't forget the unit. When you copy it down, please write 20 times 10 to the minus 6. Otherwise, a lot of students making a silly mistake. So this is very common mistake, very, very common mistake, Frustrating if I look at it. Oh my God, this student forgot the unit, right? So now this is how I read it, okay? So if you notice here, this is times, so 80 times 10 to the power minus 6, isn't it? So become 8.0, then 10 to the power minus 5. So make sure you get the right number. Okay, make sure the right number, because I don't know why, I think all lecturers are the same. Frustrated looking at, oh my God, you forgot about the numbers. So if you have this, you're not going to be very far from the answers. So remember, the answers is what? I put there 5,500, right? Per second, isn't it? Right? So, yeah, I just plot on the Excel, right? And if you extrapolate that, okay, you got the intercept. Okay, so this is the intercept. Okay, okay, and forget about the R squared, because we are actually looking at slope. So you have y equal to mx plus c, slope equal to m, so equal to 51497. Okay, so therefore the rate here, okay, you have bought 51,000. Am I right? So it's positive, not negative. Right? Sorry, it's positive. 51 because the slope. If it is like this, then it's negative. 51497 per second. Okay. Got that? Okay. So just give me 5 minutes. Also have class. I'm not langkabut. Just anyway. Yeah, quickly. So this part here. So the frozen dye, when it was irradiated, you can try this at home. Okay, you can try this at home. Okay, by 350 nanometer light was studied in the presence of quenching agent. So still, this is biomolecular. The following intensity were observed. So you have right, without and with, right, without and with, okay, without and with, without quenching, quencher, with quencher, okay, we have that, okay. And remember, this is millimolar, okay, concentration is mole per liter or mole per decimeter, millimolar, so which means this value here 0.001, okay, 0.001, okay. The second question also the same. This is millimolar. So, they are same, sorry, they are same. Millimolar, not that one, this one. Right? Nanosecond. Nano 10 to the power of minus 9. Don't forget. 10 to the power of minus 9. Okay? If you don't write this, if you don't write properly, millimolar and nanosecond, okay, what happened? You don't get the answer because this is 10 minus 9, this is 10 to the minus 3. All right. Okay, this is where students they don't get it right. Right? The idea is there, but they don't get it right. Okay, so for this particular questions, you can try it out. Right? So I'm looking at your plot. Okay, mentioned just now. Okay, so you get remember, you get the this value here. Okay, you get that value there from the slope of your plot, but it's not finished yet. It's not finished yet, isn't it? Right? So the second one, you get the slope. Right? Intercept and slope. So the slope here and intercept, which means you have the KF here, right? Then you can actually use the fluorescence rate constant, okay, into the equations, and you get, because you have the slope, right? Then you get the value for your quencher rate constant. Very easy actually, just that where students always make mistake, common mistake, millimolar and nanoseconds. That's very common mistake. All right. Okay, guys, that's it. So next week is Raya. Wednesday next week. All right. I think I'm traveling back as well, balik kampung. Right. Those who cannot balik kampung too, I'm sorry. I mean, I still enjoy and stay safe. Right. No class. Okay. Be crazy if asking you. It'd be crazy if asking you to have a class next week, because the following day, Thursday, is Hari Raya. So, selamat Hari Raya. Yeah. And many forgiving. Forgive me for anything that I said, maybe offend you, or a bit harsh. That being me, I don't know. Sometimes I cannot see that I'm wrong, right? So there's a problem with me. So I'm slip on my tongue. Yeah, I actually beg for your forgiveness, and please, right? Be safe. Wear your mask, right? No matter when other people actually telling you what COVID, and so on. So who cares, right? So stay safe, right? Keep your distance, right? Jangan salam-salam, and happy holiday.